All right, so today we are going to talk about absolute value equations. So who can tell me what absolute value means? Alyssa.
Any number, wait, it's a number away, or a number starting from 0 or away from 0.
Okay, close. It's really good. It is a number from 0. What is it? What is the word? I'm looking for a certain word about it from 0. A number's what from 0?
Oh,
yeah.
Distance.
Yes, it's a number's distance from 0. Okay, so distance. Let's think about this. So one of the examples that I will use, thanks to another teacher, for distance is to teach you guys this next concept is the track. So my cross-country runners like to run the opposite way on the track sometimes because they don't always run the same direction. It's not like track and field. So they like to run the opposite way. So a track is 400 meters. If they run the right way versus the right way, wrong way versus the right way, doesn't matter. Are they still running 400 meters?
Yes.
So it's not like they've lost distance because they're running backwards?
No.
So distance is always positive. It doesn't matter which direction you're going, it's always positive. It doesn't matter if you've come to school and then you go home. It's not like because you drove 2 miles to school and you go home, it's like those 2 miles didn't disappear or anything. You drove 2 miles home again, right? It's still positive. So just so you know, absolute value is always positive. Always positive because distance is positive. So just a few little notes about absolute value before we get into a little bit more with it. And we do some examples. So before we get into some examples, or we'll get into examples in a second, then I'll explain the next part. All right. Everybody ready? Okay, so absolute value is an equation that contains an absolute value. So an absolute value equation is an equation that contains an absolute value expression. Absolute value is denoted by these bars. So these bars mean absolute value. Just so you realize that. So if you see that, you know that that means absolute value. In absolute value equations such that absolute value of ax plus b equals c, c must be greater than or equal to 0. What that's saying is that absolute value always equals a positive number. Okay, so here's the next part that you guys got to understand here. And ax plus b equals c, or ax plus b equals negative c. Why? Why is that the case? So let's look at a number line. And I'm at 0. What if I say that my distance from 0 is 5? Where could I be on my number line? Where could I be on my number line if my distance from 0 is 5? Riley?
You could either be on positive 5 or negative 5.
So that's where this positive and negative c comes from, because you can either go to the the right 5 or to the left 5. If you go to the left 5, you're going in the negative direction. If you go to the right 5, you're going in the positive direction. Absolute value typically has 2 solutions. Not always, but typically has 2 solutions because you can go to the left the distance or you can go to the right the distance. So that's going to be one of the hardest things for you guys to remember, is to make sure you find both of those solutions. So there's typically 2 solutions. Do not forget to find both. Not always, but typically. Bless you. Finally, extraneous solution. An extraneous solution is a solution that comes from solving the problem. So you'll solve the problem and you'll get x equals something. It will look like it's a solution. It will appear like it's a solution, but really it's not a solution at all. If you go to plug it back in and check it, it's not going to work. That's considered an extraneous solution because it's something that you found. You found that x was this number, but when you plug it back in, it doesn't work. So you know how your teachers last year made you check everything? This is why. Because sometimes you're going to get extraneous solutions. Now, when you're solving a normal equation, you will not get an extraneous solution. But in absolute value, it's possible to get an extraneous solution. And why is that? Why is it possible to get extraneous solutions? Well, the absolute value of a number cannot equal a negative number. So if it makes that other side negative, then we have an issue. Because absolute value can never equal a negative number. So if you take the absolute value of something, it cannot equal a negative number. Okay? So that's sometimes when these extraneous solutions happen, is when we go to plug back in and we're trying to take the absolute value of something and it equals a negative number. That's not going to work for us. All right? So that's where these extraneous solutions come from. So yes, on your homework, when you ask if you need to check everything, the answer is yes for absolute value. Okay? To make sure that you're doing it right. Have I taught you guys how to put fractions into your calculators?
Yes.
Use that button, okay? Who needs a calculator before we get started? All right. So let's go ahead and do some examples together then, and then we will go ahead and get your homework out. Okay, so let's start with the first one. The absolute value of x equals 4. So what we know is that x could have been to the right 4, or x could have been to the left 4. Because if you're thinking about a number line, it's the number's distance from 0. In this case, some of them it's not from 0, but you're saying that you could have gone 4 this way or 4 that way. So you can write up your solution like this, or you can use what I call set brackets. Actually, I don't call them that. That's what math calls them. It's set notation. And you just list them from least to greatest inside of the brackets. It doesn't matter which way you write it up. But then we need to check it to make sure it works. So is the absolute value of positive 4, 4? Is the absolute value of positive 4, 4? Yes, so that's fine. Is the absolute value of negative 4, 4? Yes, no matter what you put inside of the absolute value, it's always going to come out as no matter what you put inside, it will always come out positive. So it doesn't matter if it's positive, it's going to stay positive. If it's negative, it's going to go positive. So don't switch the sign. That's not how that works. No, there's not an absolute value button on your calculator. Good question. I know that's what you were all thinking. All right. So again, it splits into 2 equations. So this is saying you can go to the right 9 or to the left 9. So, Mike, what would my 2 equations be then? So when you do it, you drop the absolute value bars. So I dropped the absolute value bars, and I went to the right 4 or to the left 4. So in this case, if we drop the absolute value bars, you have what left over? What's inside the absolute value bars?
Oh, r minus 7.
R minus 7 equals? Or r minus 7 equals,
Negative.
there you go. Now in this case, r is not by itself yet, so we still have to continue to solve. So all we're saying in absolute value, remember it's a number's distance. So when you're talking about a number line, you can go to the left or to the right to get the distance. So to the right is the positive and to the left is the negative. So I go to finish solving this and I add 7 to both sides. So those are our answers. So it's either, you can write it up like that or you can write it up in set notation. It does not matter which way you do it. Let me circle answers so you know which ones are the answers. But I guess I shouldn't have circled it yet because we haven't checked it, right? So we need to go about checking this. So we plug it in to see if it works. So if I do 16, the absolute value of 16 minus 7 equals 9. So that's the absolute value of 9 equals 9. Is that true? Okay. Or the absolute value of negative 2 minus 7 equals 9. Is the absolute value of negative 9 9? Is that true? Yep, it always comes out positive. So those are definitely answers that work. We do not have any extraneous solutions. Okay, what questions do you guys have so far? Okay, Jana, how about the next one there? What would my two answers, or what would my two equations be? Okay, so the next point I'm going to bring up here, she did a fantastic job, so nothing you did wrong, just a point that I want to bring up. Notice, did we change the signs inside of the absolute value at all? Did you change the signs that are inside the absolute value at all in either of these problems? No, never change the sign that's inside the absolute value. You only change the sign that it's equal to. So that becomes 3 and negative 3. You're looking at that number as the number's distance. So you can go 3 to the right or 3 to the left from wherever that point is at. Now the point doesn't always have to start at 0. Say we are starting at negative 4 and we're saying you can go 3 to the right and 3 to the left. The point being you can go either way on a number line. Okay, so we go to solve it because x isn't alone yet. And our ultimate goal is to get x alone. Or you can write it in set notation. So then you check to make sure that your solutions work. So I do negative 1 plus 4, absolute value equals 3. Is the absolute value of 3, 3? Okay. If I do the absolute value of negative 7 plus 4 equals 3, is the absolute value of negative 3, 3? So do they both work? Okay. So we do not have extraneous solutions. All right, look at that and see what questions you have for me before we get into some more challenging problems. Look at it and see what questions you have for me before we get into more challenging problems. Yes?
Wait, so wouldn't this be negative instead of a positive? Or was it?
Well, when you take you have to put the absolute value bars around it. You have to go back to the original to plug it back into it, and there's absolute value bars around
So
it.
it would,
And the absolute value only around like that side. So it would have absolute value bars around negative 7 plus 4. And when you take the absolute value, it's always positive.
okay.
Yeah, guys, make sure, so that's another point that I should have made. When you go to check it, always go back to the very, very original problem. Okay? Everybody understand that? Which has absolute value bars in it, doesn't it? So the only way to drop those absolute value bars is if you split the equations. The absolute value bar should stay on your equation until you've split it. Does that make sense? I can't speak. Yes. Your name is Josh. Josh.
Yeah.
Sorry. If you remember, raise your hand again and I'll call you, okay? All right. Don't forget to check for extraneous solutions as we're doing these problems. So just a few things that I would like you guys to think about. So I'm going to write some stuff up here. So number 1, the absolute value expression must be isolated first. No matter what you're doing, your absolute value expression must be isolated first. Who can tell me what isolated means? Who can tell me what isolated means? Mike? By itself. You cannot do anything until it's by itself. You cannot drop the absolute value bars until it's by itself. You cannot check if it's a no solution problem until it's by itself. You must first isolate the absolute value. Number 2, once isolated, make sure it is not equal to a negative. Comma, if equal to a positive, make your 2 mini equations. So once it is isolated, make sure it is not equal to a negative. If equal to a positive, you're going to make your 2 mini equations. You guys have more space than me because you have white space around, so you can always use the white space around your notes too. And then isolate the variable in each mini equation. If you can't see something, let me know and I'll read it out loud to you guys. And then finally, check for extraneous solutions. Alright, so go ahead and get that stuff written down, then we're going to get into these examples. If you can't see something, please let me know. All right. So the first thing we need to do is make sure that the absolute value is isolated. So this expression here is the absolute value expression. Grace, is our absolute value expression isolated? Why not? Then it doesn't matter if you know what the variable equals. Being isolated means there's nothing around outside of that box. Is there anything outside of that box on the same side of the equation? No, so is it isolated? Yes, it is. So if there's nothing outside of that box, that's the expression within it, okay? Then you are isolated, which means you can go on to step 2. So once it is isolated, make sure it is not equal to a negative number. Is it equal to a negative number? Is Is 18.9 negative? No, the reason you must check for this is that absolute value must always come out as a positive. So if it equals a negative number, it's not even possible and it's no solution. But this is possible. So if it's positive, you split into your two equations. So Jayla, go ahead and tell me my two equations. Good, and? All right, so once you've done that, isolate the variable in both equations. So I'm going to subtract 4.1. And I'm going to subtract 4.1. Check me and make sure. I think that's negative 23. If I'm wrong, let me know. So my solutions that I think that they are S equals 14.8. Sorry, I don't know why I'm rewriting that like that. And negative 23. But we need to make sure that those actually work. So to make sure they actually work, I'm going to do a check. Going all the way back to the original. And it's okay to use your calculator. Jordan, is your hand up? You're good. So if we do a check and I plug in 14.8. If I do 14.8 plus 4.1 equals 18.9. Is the absolute value of 18.9 equal to 18.9? Yeah, so that works. So then I have to do negative 23 plus 4.1 equals 18.9. And I get negative 18.9, absolute value equals 18.9. Is the absolute value of negative 18.9 18.9? Yes, so we can keep both of our solutions. Again, the squiggly bracket, the braces there is what they're called, are set notation. So the next one there, absolute value of y minus 8 is equal to negative 6. So the first thing, Tanari, we need to check is if that absolute value expression is isolated. Is it isolated? No. So if you put a box around it, is there anything outside of it on the same side of the equation?
No.
No, so is it isolated? Yeah. It's isolated, okay. So, Connor, I then need to check to make sure it's not equal to a negative. Is it equal to a negative? It is. What does that mean since it's equal to a negative? Can you take the absolute value of something and get a negative number? So what should we write down? You hold your hand up. Kaylee, what should you write down?
No solution.
No solution. Why? I'm going to explain why on here. You don't have to technically do this in your homework, but I would here. Because the absolute value cannot equal a negative number. Okay. So I put a box around the absolute value part. I put a box around the absolute value part. Is it isolated? RC, sorry, I'm supposed to do DC. RC, is that isolated?
No.
No, why isn't it isolated?
Because there's
Okay, and what is happening with this 4 and the absolute value? What operation is that? Multiplication. So before I say anything, never distribute into an absolute value. I know some of you will. Stop that right now. As RC said, this is being multiplied, but that doesn't mean you can distribute it, okay? We have to undo it. How do you undo multiplication, RC? So we're going to divide by 4 on both sides. We do not drop the absolute value bars until we've split into 2 equations. Again, you do not drop the absolute value bars until you've split into 2 equations. When can you drop the absolute value bars? When you have the 2 equations, so do not do that until then. So once you've isolated that absolute value, you have done that here, make sure it is not equal to a negative. Is this equal to a negative? No, so we're good there, so it's positive, so you can create your 2 mini equations. So Colin, what are my 2 mini equations?
Alright, okay, one would be m plus 9 equals 5, and the other would be m plus 9 equals negative 5.
Good, you can go 5 to the right or 5 to the left from whatever your point is that you started at. Justin. No, it's multiplied together, so the 4's cancel out here. 4 divided by 4 is 1. Good question. All right, so then we get m equals negative 4 and m equals negative 14. Did somebody just say they were confused? Did somebody just say I'm so confused? Okay, just want to make sure. Want to catch that if you guys are. I don't want you guys to be confused. Please ask questions if you are confused. So then we check it. Going back to the original. Here's where you're going to do things wrong because you must follow an order of operations. So do not forget your order of operations. Just so you know, absolute value is like parentheses. They're not parentheses, but absolute value goes into this part, so you must do that first. So when you go to check it, you must do what's inside of the absolute value first. So I get 4 absolute value of negative 5 equals 20. Which is 4 times positive 5, because the absolute value of negative 5 is positive 5, which is a true statement. That works. Again, make sure you're following order of operations. You must do all the absolute value first. We're going to skip example 7, so I'm just going to do this one underneath it. So we'll do 4 times the absolute value of negative 4 plus 9. Equals 20. So that's 4 times the absolute value of 5. The absolute value of a positive 5 is? What's the absolute value of positive 5? It's always? It's just 5. It's always positive. And that's where a lot of you guys will make a mistake too. You want to switch the sign because you do that with a negative, right? But distance is always positive. So it doesn't matter if it's negative or positive inside of there. So both of your answers work, so you are good there. Okay, before we move on to the last slide, I'm going to skip that example there. Before we move on to the last slide, what questions do you guys have for me? Yes, Mike? Here? The absolute value of a negative 5 is a positive 5. So I took the absolute value of it and got 5. In this case, I took the absolute value of a positive 5 and got 5. No matter what, when you take the absolute value, it will always come out positive. So it doesn't matter if it's a positive or a negative number, it will always come out positive. Okay? Do you have a different question? Was that the same question you were kind of asking? Oh, sorry. All right, then let's look at the next slide. So go ahead and get down there. I'm going to make sure everybody's done writing. You done writing? You still writing?
No.
Are you sure it's okay? I can wait. Okay, so we've done one like number 8. So let's look at number 9. Let's look at number 9. We're going to do a few more problems. We're going to do 9, 10, and 11. And then I'll get you guys your homework. So you have to isolate. The very first step is to isolate what's inside of the absolute value there. So, Connor in the back. Is it isolated?
No.
No, what must you do first to isolate it?
Divide the -2.
But I can't divide by -2 yet because this -3 is in the way.
Oh.
What do I have to do first?
Add 3 to the -11.
Yes, we add 3 to the -11. Notice it is equal to a negative number, but you do not check that until it is isolated. You do not check to see if it's equal to a negative number until it's isolated. The very first step is to isolate. Now, Connor, what can I do?
Divide the -2 by the 5x minus 1 and the -8.
So those cancel out, so you're left with the absolute value of 5x minus 1. I do not take the absolute value off until I've split into 2 equations. Okay, at this point you can check. Is it equal to a negative number here? Is this equal to a negative number? No. So you're fine there. So Blaine, what? It's okay, I'll wait. When you're ready, let me know. What are your 2 equations?
5x minus 1 equals 4.
And?
5x minus 1 equals -4.
Perfect. So you can go to the right 4 or to the left 4? Negative 4, sorry. Or to the left 4. Justin, did you have a question? Are you sure? Okay, once you split into 2 equations, you can drop the absolute value. Jordan, you okay? All right, head up. So I get 5x equals 5. So x equals 1. And I get 5x equals -3, so x is equal to -3 over 5. Just leave it like that. Does everybody know how to put -3 over 5 in their calculator? Okay, order of operations is going to be super important here. Again, I'm not going to be doing example 8, so I'm just going to cross it off and I'm going to do my check up here. Okay, order of operations. We start with what's inside of the absolute value, right? That's the P part of order of operations. You do exponents, then you do multiplication, division, read left to right, then addition, subtraction, read left to right. So if I check this, to plug into the original, so you start what's inside of the absolute value. So I get 5 minus 1 inside of the absolute value. Then I have the absolute value of 4. So I'm going to stop there. Do you guys have questions for me so far? Notice these absolute value bars kind of look like the number 1. Don't confuse it. I know it gets really confusing really easy. A lot of kids get confused about that when it comes to the end of course exam. Know that what those absolute value bars are and know how to use them. Do you have questions? So what is the absolute value of 4?
4.
So I have 2 times 4 minus 3. So that's -8 minus 3 is equal to -11. Is that true? It's -8 minus 3, -11?
Yes.
And that's good. So we can keep that answer. So go ahead and write that check down and see what questions you guys have for me so far. Tanari, are you okay?
Yeah, I got
Are you sure?
it. Yeah.
It's okay. You can always ask questions, okay? Alright, so now we need to do the check of the other one. So now we need to do the check of the other one. So we're going to check it. Plug it into the original, so that's -2 times the absolute value of 5 times -3/5 minus 1. Everybody know how to put that fraction into their calculator when they go to do 5 times -3/5?
Yes.
Anybody not know how to do it? Please go ahead and do 5 times -3/5 in your calculators now when you get the chance. Yes.
Did that say like 41 on the right?
Where are you at? That would be just absolute value of 4. The absolute value bar looks like a 1. Yeah. Like I was saying, they look like 1. So that's a good clarification right there. So what's 5 times -3/5? What did you get in your calculators? -3. So I get -2 times the absolute value of -4. What is the absolute value of -4? What is the absolute value of -4? 4. So I have -2 times 4 minus 3 equals -11. So -8 minus 3 equals -11. Is that true?
Yes.
Yes, so both our answers work. It doesn't matter which way you want to write it up. I just want you to know that they both work. Okay, I'm just going to do example 10 with you guys, and then we're going to be done with notes for the day. I'm going to have you guys get your homework out and start practicing it so you can ask me any questions you have. All right, I'm going to move number 10 over here so that I can actually do it. All right, is this isolated here? Is that isolated? Yes, so I can split into my two equations. This seems confusing, but it's not that bad. Brian, what would my two equations be for number 10? It's the same problem, I just moved it over. Number 10's right here. This is already isolated, so what would my two equations be? When we got to this point here, remember we do the positive and the negative of the thing outside. So what would this look like? No, we never change what's inside of the absolute value. So it would be x plus equals and x perfect. So we solve it. So x equals 6. And x equals -2. Let's do the check down here to make sure. And you're probably thinking, Mrs. Brady, they've all worked so far. Why are you making me check it? Here's why. In this one, you're going to have an extraneous solution. So if you plug in x is 6, so 6 plus 6 equals 2 times 6. So do you see how there's multiple x's in this one? Do you see how I have to put in for this x and this x? And you use the same number both times. So I do the absolute value of 12 is 12. Is that true? Is the absolute value of 12 12? Okay. So that one is okay. That's not extraneous. But if I do negative 2 plus 6 equals 2 times negative 2, I get the absolute value of 4 equals negative 4. Is that extraneous? Is that possible? Can you take the absolute value of something and get a negative number? No, not possible. So that does not work, and that is an extraneous solution. So that's an extraneous solution. You just cross it off. All right, so just a few things here.